Here we have a class 2 double insulated, there's the symbol, square inside of a square, electric drill. This particular drill is a variable speed, so inside of this area here is the speed control circuitry, typically a diac firing the gate of a triac or a back-to-back SCR control for the phase clipping for speed control. So this end here is the gearbox. We have the chuck, of course, a bearing, then we have the gearbox. Here we have the fields, and the commutator of the armature. See there the armature windings inside of the main field poles. This particular motor is known as a series motor. The reason for that is that the armature windings and the field poles are connected in series. This particular motor can actually run on AC or DC and is often referred to as a series universal motor. I've removed the brushes. This is what the brush would look like. Little spring there, and we have a little bit of RFI suppression on those two brush connections. Here's your rear bearing, and the brushes run against the commutator segments, and that is how the current is supplied into the armature of the motor. These motors have very high torque at low speeds. One thing you must be careful of if you remove this motor for some other purpose is to not run it without a mechanical load connected to the shaft. They can overspeed to such an extent that they can self-destruct. They are a very robust motor and found throughout the world in power tools. So your skill saws, or your circular saws, your angle grinders, your electric drills, and then into the home appliances. We have them in our mixers and food processors, vacuum cleaners, just to mention some of the applications for the series universal motor. So there we have, in case you're sort of ever curious about what is inside of a typical power electric drill. There's not too much to them. Thank you for viewing, and hopefully that is able to take care of some of your curiosity of what you'd expect to find when taking apart a powered electric drill. Catch you in a later one.